Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. Alright, this video has to do with solving right triangles using trig functions. Now, what does it mean to solve a right triangle? Well, there are some basic things you have to remember about any kind of right triangle. And the idea to solve it means that given a little bit of information, you should be able to figure out the length of all three sides of the triangle and all three angles. Now, the key, of course, is you already know one of the angles, and that's this one right here. If we're talking right triangles, of course, one of those angles has to be 90 degrees. All right, well, the longest side, of course, across from the right angle is the hypotenuse. And I'm just kind of reviewing something you should already know. The two sides of the triangle that come together to make the right angle, those are called legs. Okay? Now, you need to remember the sine, cosine, and tangent functions. These are called trig functions. So sine equals opposite over hypotenuse. Cosine is the ratio that relates the adjacent leg to the hypotenuse. And tangent, which we abbreviate tan, is opposite over adjacent. So this is something you have to memorize. These are definitions of how two sides of a triangle relate to each other in a right triangle. And in some textbooks or some classrooms, they have this mnemonic, this memory device that is so, ka, toa. Let me finish writing that. Sokatoa. And if you say it really fast, sokatoa, it sounds like soaking toes. So think about soaking your toes after a long day skiing. You're getting rid of the frostbite. You're soaking them in nice warm water. It feels good. Or it's a long day. You've been on your feet all day and you're going to sit down and relax, soak your toes for a little while. And the idea is that's how you remember. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Another quick thing to remember is the sine and the cosine functions all have to do with the hypotenuse. Notice the h in each one of them. So the hypotenuse is in a ratio with either of the legs. Okay, that's sine and cosine. The tangent has both legs put together in a ratio. The tangent always involves the two sides that make the right angle. Now, to solve right triangles, there are some rules to remember. The rules are, number one, use the Pythagorean Theorem to find the missing third side. So you have to know two of the three sides already. Number two, use the trig ratios that I have listed in green above to find a missing side. Number three, use the inverse functions to find a missing angle, and I'll show you an example of that. And number four, all angles of the triangle, it's a right triangle, so they add up to 180 degrees. Alright, to finish this video off, I'm going to do one example with you because we're going over the basics. And then look for some other videos in this series that have the same title, but they will be problem sets, and then a self-quiz later. So this is all the information I have. I know one acute angle, 36 degrees. I know that's a right angle, of course, it's a right triangle, but this leg is 5 feet. So if I say solve this triangle, I'm looking for the length of this leg, of this hypotenuse, and of this missing leg, or missing angle. So the two easiest things to do first is if you know two out of the three sides, use Pythagorean Theorem. That will not help us here. If I know any one of those acute angles, I can find the other one because all three angles add up to 180 degrees, right? So I've got 90 plus 36, that'd be 126, and I can just go ahead and subtract. 180 minus 126 should be 54 degrees. Alright, so now I know immediately, this is the easy part, 54 degrees. Alright, next I need to find either the hypotenuse or this other leg. And I have a choice here. I can use this 36 degree angle as a reference angle and then find either the leg or the hypotenuse. or I could go ahead and use the 54-degree angle as my reference angle. Okay, so it just kind of depends. There's an easier way and a harder way to do this, but it doesn't matter. Eventually we'll get the same answer. I'm going to say that I'm going to go for this leg right here. I'm going to call that X. Now the idea is I have to remember my trig ratios, sine, cosine, and tangent. All right, let's go ahead and do some labeling here. If this is the reference degree, then this leg is the adjacent leg because it runs right into it. All right, this is the opposite leg. It's opposite, directly opposite the reference angle I'm talking about. Okay? Then I think about my trig ratios. Which one deals with the adjacent leg and the opposite leg? Right, that's going to be tangent. So tangent of 36 degrees is going to be opposite over adjacent, which is really opposite is 5, adjacent is x. All right, now on your calculator, find tangent of 36 degrees. Let's take a look at that. All right, on this calculator, it is, I type in the 36 and then I hit tangent. Okay, 0.7265. 7265. Usually we write this out to 4 decimal places, equals 5 over x. All right, I'm going to show you a little shortcut here. If your variable is in the bottom of a fraction, what you want to do is swap it out diagonally. In other words, think of it as a proportion, and now I'm going to put the x over 1, which is still x, right? And the 5 is going to be on top, and the decimal 0.7265 is replacing the x. We're going diagonal here. So think of it as a proportion and swap the diagonals. So it's a lot easier when the variable's on the top. All right, now it's just simply a matter of dividing that out, and that will be my adjacent leg. There it is. It looks like about 6.88. Depending on how accurate you want to be, let's call that 6.9. So I've got my second answer. 6.9 feet is the other leg. Now remember I said try to do the easy parts first. I have 2 of the 3 sides of a right triangle. So I can use Pythagorean Theorem and use 5 as a leg and 6.9 as a leg and find the hypotenuse. Or I can go ahead and use any combination of these 2 sides I know to find this hypotenuse. All right, let's go ahead and do the Pythagorean Theorem. So you remember that we have 1 leg squared plus the other leg squared equals the hypotenuse squared. I'll go ahead and call it h so I don't confuse it with my earlier x that I was using. All right, go ahead and multiply those out and solve. At this point, I have h squared equals 72.61. I'm going to take the square root of each side. It looks like 8.52115. Let's call that 8.5. The hypotenuse is 8.5 feet long, approximately. All right, so I've got the missing angle, I've got a missing leg, and I've got a missing hypotenuse, so I know all 3 sides, all 3 angles of this triangle. That's an example of solving right triangles. Well, thanks for watching, and continue to look for other videos under the same title, and I'll have some problem sets for you, and at the end I will have a self-quiz. Thanks for watching. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.